Hello everyone and welcome to this session. Okay, so we'll be going through limits in calculus. Then we can also do some revisions based on the exam that you guys wrote. So it's mainly calculus today. I hope I'm audible enough. So this video will be recorded and sent so that you can watch it at any other time, just in case network is bad or something. You can still have a recording of this video. I'll make sure to send the link. Okay, so like I said, we'll be doing limits. So let's go ahead and start. So our first example for today, how do we evaluate the following limits? So we have the limit. The limit as x approaches 2, we have x squared minus 4 divided by x minus 2. So how do we evaluate the limit for this particular question? Okay, so remember limits are just a matter of substituting where is x, we put whatever is approaching, then we find the value that is being required. But in this case, if we substitute x with 2, in the numerator we'll get 4 minus 4, which is a 0. Denominator will get 2 minus 2, which is a 0. Hence, it will be invalid. Okay, so I'll do it in two ways in which you can approach this question. And I'll show you, I'll guide you on how to be doing these questions. So to start with, let's say we apply the limit. Where there's x, we put 2. This is what we get. We get 2 squared minus 4 divided by 2 minus 2. This will give us 0 over 0. Now, if you have a result which is giving you 0 over 0, you have two options for this question. The first option is by first applying the difference of two squares in the numerator. Remember, we have x squared and 4, so we can apply the difference of two squares so that we get the limit as x approaches 2. The difference of two squares there will be x minus 2 in brackets and x plus 2. All this is divided by x minus 2. Now, we can clearly see that the x minus 2 and the x minus 2 can cancel out, leaving us with the limit as x approaches 2. So we're only remaining with x plus 2. Now we can do the substitutions by saying where there's x, let's replace it with 2. So that we have, this will just result to 2 plus 2. Hence, the limit is 4. So this is one way of doing it. So the other way of doing it, on the condition that you have this result, 0 over 0, is by applying what is known as the L'Hopital's rule. So L'Hopital's rule. So L'Hopital's rule is used when you have this kind of scenario, 0 over 0, or when you have infinity over infinity. We'll take an example similar to that so that you understand what we're talking about. So this is just by using the difference of two squares, then you have that. So now let's apply L'Hopital's rule. So according to L'Hopital's rule, if you have such a scenario, 0 over 0, what you do is you're going to take the derivative of both the numerator and the denominator. So the derivative of 2x, of x squared is 2x. The derivative of 4 is a constant, so the derivative is 0, divided by the derivative of x is 1. 2 is a constant, so the derivative is 0. So what we have is simply the limit as x, not h, approaches 2 of 2x. So we just apply the limit by substituting x with 2, hence we get 2 times 2, which will result to this form, the same form that you had there. So this method of difference of two squares is limited because some questions will not require you to use the difference of two squares, meaning that at some point when you have 0 over 0, you have to use L'Hopital's rule. And we'll look at examples that are restricted only to the L'Hopital's rule. Let's take another example. So in this example, this one is pretty straightforward. In this example, we have the limit as x approaches 3, then the expression there is x squared minus 3x plus 2, like that. So this one is straightforward. Where there's x, just replace it with the 3. So what do we get? 9 minus 9 plus 2. This results to 2, like that. As simple as that. Okay, so another example. This one is similar to the one which has the difference of two squares. So this one is the limit as, let me just do this. The limit as x approaches 4. As x approaches 4, then what we have is root x minus 2, the root of x minus 2 divided by 4 minus x. So we have root x minus 2 divided by 4 minus x. Okay. So for this one, if we replace 4 there, we get a 0. Replace 4 there, we get a 0. Then you can use L'Hopital's rule, or you can just use the difference of two squares. Now, the difference of two squares that we're going to use here will be like this. We're going to say this is equals to the limit as x approaches 4. Then the numerator is okay as it is, so we'll leave it as the root of x minus 2. But the denominator, this 4, we'll write it as 2 squared, so it becomes a square. This x, we'll write it as x squared with a root. Understand that 2 squared is just the same as 4. X squared under a root is just the same as x, because the square root will cancel with the square. Hence, this will result to the limit as x approaches 4. So numerator, we have root x minus 2. Denominator, difference of two squares. So we'll have 2 minus root x. The other one is 2 plus root x, like that. Then from there now, we can say, what does this result to? So this will result to, now first of all, we cannot cancel this 2 because the 2 is positive here, the 2 there is negative, here the root is negative. So for this first bracket that we have here, we're going to factor out a negative. This is what we mean. We're saying that we have the limit as x approaches 4. We have the root of x minus 2. Now this part that we have here, we can factor out a negative. So if you factor out a negative, it means that This one, the root x, which is negative, becomes positive, and the 2, which is positive, becomes negative, like that. Then open bracket 2 plus the root of x. Okay, so this is what we have. At this stage, it's clear that this and this can just cancel out. So what remains in this case is just the limit. As x approaches 4, then what we have is 1 negative 2 plus root x. Okay, as simple as that. Now let's apply the limit. So if we apply the limit in this case, this is what we're going to get. We're going to get 1 divided by the negative, which is outside, open bracket, 2 plus, remember where there's x, we replace it with a 4, so the root of 4 is simply 2. So our answer will be negative 1 over 4. That's it. That's our answer for this particular question. Okay, so we have another one. The limit as x approaches, let's use h, as h approaches 0, we have 2 plus h in brackets raised to the power 4 minus 16 divided by h. Okay, so for this particular question, So for this one, the first we're going to do is we're going to need to expand, because at this stage, if we decide to replace h with 0, we'll get a 0 here and a 0 in the numerator, because this will just give us 2 to the power 4, which is 16. 16 minus 16, which is a 0. So we need to expand. So if we're to expand, this is what will happen. What we have is 2 plus h, which is raised to the power 4, of course. So I'll expand power 2. So power 2 will be 2 plus h. I want to do it in steps. If you know how to expand using binomial, even better, that's fine. You can just use binomial straight ahead to give you the answer faster. So 2 times 2, that is a 4. 2 times h, that is 2h, plus another 2h, plus h squared. So this will give you 4 plus 4h plus h squared. Now, since this is squared, then we can just say another squared, so to have a power 4, meaning that this bracket will multiply by itself. So once you do your expansion, this is what you can get. So let me also show you how you can do it using binomial, just in case you've forgotten. Let's use binomial to expand. So we need to list down the coefficients for 4 from the past course, which is 1. We have 4, we have 6, we have 4, and 1 again. And remember, there's that 16, so we can say minus 16 somewhere here. Okay. Then the next thing we're going to do is the first term will descend. So the first term will be 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, and 2 to the power 0. So it has descended like that. The next thing is h will ascend. Now, if h is ascending, then we're going to have h power 0 here, which is just 1. This is h squared. This is h to the power 3. And lastly, this is h to the power 4. Remember, everything is over h. Let's simplify things here. This is how we can simplify what we have. So we can say the limit as h approaches 0, okay? 2 to the power 4 is 16. Now, since this is a positive 16, we have a negative 16, meaning that this and this will just cancel. 4 times 2 to the 3, that is 4 times 8. Hence, we get 32. So, 32h. This is 4 times 6, that is 24. H squared. This part here will just give us 8h power 3. And this part here will give us h to the power 4. Everything is over h. Okay. So we factor out h because it's common. So I can say we factor out h like this. What do we remain with? 32 plus 24h plus 8h squared plus h power 3. All this divided by h. Then this h and this h will cancel. So if that's the case, then we have the limit as h approaches 0. So what do we remain with here? Remember, we have 32 plus 24h plus 8h squared plus h cubed. Okay, so if we apply the limit, it means that where there's h, we just replace it with 0. So we have 32 plus, we put a 0 there, 0, put a 0 there, 0, put a 0 there, 0. So it will be 0 plus 0 plus 0, which is just 1, 0. And this is just result to 32. So that's our final result. Okay. Okay, so let's move on. So now let's tackle the tutorial sheet questions. The questions from the tutorial sheet which have limits as well as questions on continuity. So let's just do that. Okay, so let's start with, for example, question 2. The question says, determine whether the following piecewise functions is continuous at x is equals to 1. So these are continuous functions questions. So the question is, we're determining whether it's continuous at x is equals to 1. So this is what we're going to do. We have f of x. So f of x is equals to, let's do this, x cubed minus 1 divided by x minus 1. Here we have it 2. We have x is not equals to 1. And here we have x is equals to 1. Okay. So we've been told that we're testing whether it is continuous at 1. Now, what we're going to do is we're going to find the limits. And once we find the limits, we'll have to check if what we get will be the same, then we can conclude. This is what we mean. So in this case, the function is just this one that we have here. The function will be f of x is equals to x cubed minus 1 over x minus 1. That's what we have. So to find the limits in this case, as it approaches the value that we're looking for, remember, we were told that we were testing if it's continuous at 1. So to do that, we can clearly see that we can use L'Hopital by saying limit as x approaches 1. So now, in this case, we have x power 3 minus 1 over x minus 1. So let's apply the L'Hopital's rule by differentiating. So we can say limit as x approaches 1, then this what we get? We'll get 3x divided by, what's the derivative there? 1. So what does this give us? This gives us the limit as x approaches 1 of 3x, sorry. So if we replace the x with the 1, what we'll get is simply 3. And the 3 is not equal to this value here, meaning that it is not continuous. Okay. Let's test something else so I can understand what is happening. So this time around, let's bring in a trigonometric function, sine x over x. We test that it is continuous at x is equal to 0. So the piecewise function is f of x is equals to sine x over x. So we're saying x in this case is not equal to 0, but we have a function f of x equals to 1, then we're testing if it's equals to 0. Okay. So now we're going to apply the limit as x approaches 0, as stated there, of the function which is given, which is sine x over x. Okay. So of the function sine x over x. So this will result to, now if we introduce a 0 there, to be 0 over 0, hence we need to use L'Hopital's rule. According to L'Hopital's rule, we have to differentiate the numerator. So differentiating sine, change to a cos. Differentiating x will just be 1. So in this case, we have the limit as x approaches 0 of cos x. So where there's x, let's replace with a 0. So what we get will be the cos of 0. Now the cos of 0 is equals to 1. This one that we've got in here is the same one that we have there, meaning that this particular function is continuous at x is equals to 0. That's how it's done. We're getting somewhere with these piecewise functions. Let's do a similar example, which is question 4 from the tutorial sheet. So f of x, this time around, f of x is equals to, we have x minus 2 divided by root x minus root 2. So x is not equals to 2, but 4 over root 2 when x is equals to 2. This is what we have. Okay. So how do we deal with this piecewise function? So we're testing if it is continuous at x is equals to 2. So based on the function that we have been given there, remember f of x is equals to this function. So based on that function that we have, let's apply the limit. So the limit as x approaches 2. What's the function? This one here. The function is x minus 2 root x minus root 2. So the limit as x approaches 2. So for this part, we're going to apply the difference of two squares. This x that you see here can be written as x squared and a root. Same thing, this 2 can be written as 2 squared and a root divided by root x minus root 2. Why are we doing this? Remember, x squared with a root. The root and the square will just cancel, we'll go back to x. Same thing with the 2. Now, according to the difference of two squares, we know that a plus b, a minus b is equals to a squared minus b squared. So these two are squares now. So since they are squares, we can apply the difference of two squares. So this will result to the limit as x approaches 2, we have x minus 2, they are all in roots, and x plus 2, they're also in roots, divided by x minus root 2. Now, at this stage, it's clear that this and this will just cancel, leaving us with x root x plus 2. So now let's bring it here. What we have now is the limit as x approaches 2, like that, of the function root x plus root 2. Let's apply the limit. So where there's x, let's replace it with a 2. What we get? We'll get root 2 plus root 2, like that. Now, what is root 2 plus root 2? Root 2 plus root 2 is just the same as 2 root 2. This is not x, sorry, this is supposed to be 2. Okay, so this will give us 2 root 2. Then let's rationalize. We'll multiply it with root 2. We'll multiply this with root 2. What do we get? 2 root 2 times root 2 will give us 2 the root of 4 divided by root 2. So this will give us 2 times the square root of 4 is 2 over root 2. This will result to 4 over the root of 2, which is just the same as what we have here. Now look at this. From the previous question, we said that this one that you see here is the same as this one that we got here. Hence it is continuous. Same thing. This is the same as this. But from the other question that we did, we saw that we got a 3 and there we got a 2. So this one not the same. So for this question, this function was not continuous, but for these two, the function is continuous because we get the same result. I hope that's okay. Okay. Okay, so let's move on now. Here's a question. Let's see how we can find the limit. It's also coming from the tutorial sheet, and it has trigonometric functions. So let's see how we can break it down. So the question is, the limit as x approaches 0, we have 1 minus cos x sine, oh sorry, x sine x. X sine x. Okay. So how do we find the limit? If we try to find the limit by going direct, this is what we're going to get. So we can say this will imply that the limit, or rather we're applying the limit. So we can have 1 minus cos, where does x replace the 0, divided by, where does x there, replace the 0, sine 0. What does this give us? This will give us 1 minus cos 0 is 1, divided by 0 times 0 is 0. So this is 0 over 0. This does not exist. So since you cannot divide by 0, then in such a case, you are supposed to use L'Hopital's rule. So let's use L'Hopital's rule. Now, according to the L'Hopital's rule, if you have such a scenario, 0 over 0, what you need to do is you need to take the derivative of both the numerator and the denominator. This is what we mean. So the limit as x approaches 0, you'll have the derivative of 1 is just 0. The derivative of a cos is a negative sign, like that, divided by the derivative of x sine. Now, these two functions are multiplied, so we have to go into the product rule. Our first function is u. Our second function is v, which is sine. Differentiate the two. So u prime is 1. V prime, derivative of sine is cos. The formula is uv prime plus u prime v. So what is our u? X. What is our v prime? Cos. What is our u prime? 1. And what is our v? Sine. So the derivative of x and sine is what we've got in here, which is x cos x plus sine x. So what does this give us? Numerator is the same as a positive sine x. Denominator is simply x cos x plus sine x, as it is. Let's do the substitutions. So where is x? If we substitute with 0, what do we get? This will result to sine 0 divided by, now for this part, we'll have 0 cos 0 plus sine 0. What does this give us? This gives us 0 divided by 0 plus 0. What do we get? 0 over 0. So we don't have the answer. So since we don't have the answer, remember what I said. Once you result to this, you apply L'Hopital. So since we have resulted to this, what do? We apply L'Hopital again. So to apply L'Hopital in this case, we're saying we're on this part here. This is where we are. Differentiate both the numerator and the denominator like this. So limit as x approaches 0, the derivative of sine is cos. What's the derivative of x and cos? We have to go through the product rule again. So u in this case is what is our u? What is our u? Is x. V is cos. So u prime is 1, v prime is negative sine x. We combine the two using the same formula. So this and this multiplies. Hence, we have, let's start with this two. We have cos times 1, which is just cos x. This times this, we have negative x sine x. What we get. Then from there now, we can come and substitute it here. So what do we get? We simply get cos x minus x sine x, like that. Now, this is just a derivative for this part. There's also this sign here. The derivative of this sign will simply be a cos x, like that. Okay, we've done enough, but let's just do the substitutions. So where there's x, we replace with a 0. What do we get? We'll get cos 0 is 1 divided by cos 0 here, 1. We put a 0 here, this whole thing will just be 0. So minus 0, cos 0 is 1. So denominator is just the same as 1 plus 1. So 1 over 2 is our answer. Because 1 plus 1, then that's that. So our answer for this one is half. So now let's answer a question from the exam. Let's answer a question from the exam. Let me just find the exam questions. Okay, so in the exam, I hope we all have the paper by now. Let's answer question 11. It's on section B, question B11. So answer question B11. We will answer both question A and B. I'll show you how to do it. In fact, question B11, we've already done it. Where just from doing it, this question is very similar to this one. So this question was picked from the tutorial sheet. Question B11 is this question that we did here. So I think that's okay. Okay. In case you have a question that you'd want us to go through on calculus, many limits, just send it to my inbox just now, then we can go through. Okay, so I think for now, that's what we had on limits. But in this question on trigonometry, let me just refresh your memories on trigonometry. So the question is the same question 11, question B11, A. The question says solve the equation So the equation is cot 3 theta. So we have cot 3 theta minus tan 3 theta. All this is equal to 0. How do we solve this equation? So it's important to note that we need to know the identities to start with. So cot is cos over sine, tan is sine over cos. Now, on top of that, let's make an assumption. Let's say, theta, not theta rather, but alpha, let alpha be equals to 3 theta. Let alpha be equals to 3 theta, like that. So for this one, we can say where there's 3 theta, let's put alpha, so that we have cot alpha minus tan alpha, all this is equal to 0. Now let's bring in the identities. Cot is the same as cos alpha over sine alpha minus tan is the same as sine alpha over cos alpha. All this is equal to 0. Then now we can say, let's find the LCM. The LCM is sine cos, of course. So we have sine alpha cos alpha. So this into this, we get a cos. Cos times cos, we'll get cos square alpha. This into this is sine times sine, we get sine square alpha. Remember, all this is equal to 0. Now at this stage, we can cross multiply so that cos square alpha minus sine square alpha is also 0. So if that's the case, we need to bring in an identity. Now, the identity we're going to bring in is this one. Remember this guy, sine square alpha plus cos square alpha is equal to 1, this identity. So you make one of them the subject. In this case, for example, let me make sine the subject. So I'll have sine square theta is equal to 1 minus cos square, not theta, but alpha. So here where there's sine, I'll replace it with 1 minus cos square. What do we get? We'll have cos square alpha minus, this will give us 1 minus cos square alpha. This is equal to 0, like that. So now this can become cos square alpha minus 1 plus cos square alpha, or this is also 0. So then we can say the 1 can go to the other side. The cos and the cos, they are like terms. So cos plus cos will get 2 cos square alpha is equals to 1. Remember, the 1 is negative, it goes outside, becomes positive. Okay, we need to take a root to both sides to get rid of the square. This is what will happen. Introduce a root, so that we get root 2 if the square root goes with this cos, the square and the root will cancel out, leaving us with only cos alpha, which is equals to the square root of 1. It's just 1. Now remember, we are looking for the value of theta. So let's divide both sides by root 2. So cos alpha is equals to 1 over the root of 2. So what's the value of alpha in this case? We're going to say alpha will be equals to the cos inverse of 1 over root 2. Like that. So what's the cos inverse of 1 over root 2? Let's see. I think this is the same as root 2 over 2. So it should be 45 if I'm not mistaken. So yes, I'm getting a 45. So alpha is equals to 45 degrees. Now, we are not looking for alpha, we are looking for theta. But remember, we said, we made an assumption from the beginning. We said where there's 3 theta, replace it with alpha. So, in this case, where there's alpha, we're going to bring back 3 theta. So that we say 3 theta is equals to 45 degrees. Divide both sides by 3, hence theta, in this case, is equals to 15 degrees. So that's our solution. That's how we find it. So this is from the exam paper. This was question 11. Yes, question 11. So let's look at another question. We're still in the same paper. Let's take up another question. Last time we were looking at induction, and I think we're done. So induction we went through, the ones for matrices, everything we went through. So today we're just looking at limits and anything to do with calculus. Okay, so there's this question, if I can find it, that I'd like us to go through. Yes, this one. So we did it last time, but people were saying that there were some issues they didn't understand. So I just want us to go through it again. The question is question 13a. It's under induction and it involves matrices. So let us just go through that particular question. The question is, on the left-hand side, you have 3, 6, 3, 6. This side you have 0, 1 raised to the power n. This is question 13 from the exam, 13a. This is equals to 3 to the power n. We have 3, open bracket, 3 power n minus 1, close the bracket. Here we have a 0, here we have a 1. Okay. So the best way to approach this question is, step 1, change the interpretation. This matrix that you have here, let it be any letter. For example, let it be matrix A. So let's say this is A is equals to the matrix 3, 6, 0, 1. Then this matrix now, remember this is A to the power n. So this matrix is A to the power n is equals to 3 to the power n, 3, open bracket, 3 power n minus 1. Here I have a 0, here I have 1. So this is what I've done. Here, where there's this matrix, I just put A. So A to the power n is also this, which is this expression that we have here. Now, Induction. Step 1, we have to prove that it is true for n is equals to 1, the base case, of course. So we prove that it's true for n is equals to 1, meaning that we'll say, I'll just write step 1. You know the English that you have to write, we prove that it's true for n is equals to 1. So according to step 1, I'm going to say, let me just write it. We prove for n is equals to 1. So a to the power 1 here is equals to 3 to the power 1, 3, open bracket, 3 to the power 1, which is the 3, minus 1, which is a 2. 0, 1, like that. What does this mean? This means that a to the power 1 is equals to 3, 6, 0, 1, which is this matrix here, matrix A. So is this statement true? Yes, it is true. So since step 1 is true, we'll move on to step 2. Now, step 2, this is, of course, the assumption. We have to make an assumption. So by making the assumption, we're saying that we assume that it is true for n is equals to k. Since we're making that assumption, then we're saying where there's n, we replace it with k. And that's the only thing to do. So we're going to say a to the power k is equals to, in bracket, 3 power k, 3, open bracket, 3k minus 1, 0, 1. That's the assumption. We even leave it there. Now, for those of you who were there last time, I said, let me just demarcate my working space. For those of you who were there last time, I said, you have to know the result that you're supposed to produce. And because of that, you have to write the answer even before you get there. So I'll just write it somewhere separately. It's not part of the solution. It is just there to guide you as you'll be concluding. This is what I mean. Remember step 3, we have to prove for n is equal to k plus 1. So where there's n, I'll replace it with k plus 1. So this is equals to, open bracket, 3k plus 1. This part will be 3k plus 1, 3 to the power k plus 1 minus 1. Here we have a 0, here we have a 1. So this part, where there's n, I've just replaced it with what? K plus 1. I'll leave this hanging, I'll come back to it. So now, how do we prove that it is true for n is equal to k plus 1? This is how it goes. We're going to say, using this statement, a to the power k multiplied by a to the power 1. Remember, if the bases are the same, the powers will simply add, meaning that this will be the same as a to the power k plus 1, like that. These two are the same. So if these two are the same, then what I'm going to do is this. I'm going to say a to the k, multiply it with a to the 1. What is a to the k? This guy here, from the assumption. By the way, this is step 3. Step 3, where we now prove that it's true for n is equal to k plus 1. So a to the k, the assumption, a to the 1, step 1. So let's do the substitutions. So a to the k will have 3 to the k. We have 3, open bracket, 3k minus 1. Here we have a 0, here I have a 1. Like that. That is this part. A to the 1 is this matrix here, which is 3, 6, 0, 1. Okay. So matrix multiplication now. For this part, we already said that the powers will just add. So a, k plus 1, like that, will be equals to row by column. So this row times this column. So 3 to the k times 3. 3 to the k times 3 will get 3 to the k times 3, like that. 0 times 6 is just 0. 3 to the k times 0 is just 0. 0 times 1 is just 0. This part that you see here, we'll multiply it with 3. What do we get? We'll get 3. What do we have? This part and that part. Okay, that's fine. So 3 times 3, open bracket, 3 to the k minus 1 equals 1 times 6, that is 6. This part times 0, that is 0. 1 times 1, that is 1. Now we have to manipulate this. How do we do that? So a to the power k plus 1 will be equals to, here we have 3 to the k times 3 to the 1, which is just the same as 3 to the power k plus 1. There's a 0, so just leave it like that. For this part here, let's factor out what is common. We have a 6, we have a 3. Let's factor out a 3. So if we factor out a 3, what remains? Factor out a 3 here, what remains will be 3. 3 to the k minus 1. Factor out a 3 here, what remains? 2. 0 plus 0, 0. 0 plus 1, 1. That's what we get. Now, inside the bracket, inside this bracket, let's see how we can change things. Let me just, no, it's fine. I can do it here, it's fine. So a, k plus 1 will be equals to 3 to the power k plus 1. Then for this part, there's a 3 outside, remember? This is what will happen. 3 times 3 to the k will be 3k plus 1. Because remember, this 3 has power 1, this 3 has a k, so 1 plus k is just k plus 1. This 3 times this 1 will have minus 3. Then there's a plus 2, this guy. Okay, 0 there and the 1 there. Okay, our final step. Now, in our final step, this is what will happen. We have a, k plus 1. So 3k plus 1. For this part here, we have 3. Then we have 3 to the power k plus 1. Negative 3 plus 2 is simply negative 1. Then we can close the bracket. We have a 0 and a 1 here. Okay. Now remember, I told you how to find the result before going through this. So the whole purpose of finding that result that I wrote down is so that you can come and compare the two. You can see that these two are just the same. 3k plus 1, which is that, this part, which is this part, 0 and the 1. So now if you see that these two are the same, then you can conclude that the whole statement is true by induction. Now it is difficult for you to conclude that it's true by induction here if you don't know what is true. In this case, what is true is that replacing n with k plus 1 is the same as multiplying those two matrices, a to the k and a to the 1. So if the two matrices appear the same, then it is true by induction. Okay, so thank you very much for now. We'll meet later for mathematics. Have a good day.